Hello all, welcome back. In the last video, we discussed about Java variables and naming conventions. So, in this video, we discuss another important topic related to the state of the object, that is uh, data types actually. So, we know that we store the state of the object in variables. So, but as we all aware, we'll have different types of data, right? We'll have numeric data, like which represents numbers, currency. Also, we'll also have text data, like just for examples, names, country names, like any uh, person's names, animals, or whatever. See, there will be text data, there will be numeric data, and also we'll have like some flags like true or false, which indicate true or false. So this kind of data, various kinds of data we have. So we cannot store all these categories of data in single type, right? So Java provides different types of data. It allows us to save different types of data. So we have data types. Data types are the concept like which um, caters the needs of the different types of data that objects needs to store, right? So we will see that. So we have primitive data types. Like in data types, we need to learn primitive data types. Primitive data types, if you focus on the word primitive itself says, so primitive means very basic thing, very basic. So primitive data types as per Java, like they are like they are supported by the Java platform directly, and they Java reserves some keywords for it. If you create a variable by mentioning that keyword before the variable name, then that data type will be created. So Java provides 8 types of primitive data types. They are byte, short, integer, int, float, double, character, and also string. So we will see what these data types are, when we need to use them, what type of data they will store. We'll see them one by one. Thereafter, we'll also see the examples programs of each of them, so that viewers will get clear idea and also know when to use them in actual application development. So we will see primitive types. And one more thing, uh, one more important concept is Java is a statically typed programming language. So statically typed means when we need to define the type of the variable before it is used. We need to define the type of the variable at the start itself. Without defining the data type of the variable, we will not be allowed to use that. Suppose for example, if you see, we are creating a field of the object bicycle, that is gear. So this variable gear, when we are defining it, we need to mention its data type, what type of data it will hold. So since gear is a numeric value, we mention it as data type as int. So if you don't mention this one data type, then compiler will give you the error. Statically typed means in advance it is giving. But there are some programming languages, for example take JavaScript. Actually JavaScript, you don't need to define the types of the variable. uh, you can use it directly. So the JavaScript, at the runtime itself it will decide based on what type of the data, based on the type of the data it is holding. So but that luxury Java does not provide. Java, if you want to use a variable, you need to define it well in advance before using it. So that's why we call Java statically typed programming language. So we'll see the different types of data types. Here first one is byte. So byte data type is a 8-bit integer. No, 8-bit signed to complement integer. We know this binary representation, right? So this binary representation, like we have no, signed representation, non-signed representation, which we used to which we used to represent the numbers, right? So if you see the byte data type, like its minimum value is minus 128. I mean, minimum value it can store is minus 128, and maximum value it can store is plus 127. So if your requirement is to store a numeric value in between minus 128 and 127, you can use a byte, right? So byte can allow you to store both negative as well as positive values, but remember the range is within minus 128 to 127. So beyond this value, this byte won't support it. So it's a 8-bit, like it is a 8-bit data type. 8-bit data type means like when you are using byte, the memory is allocated for 8 bits, right? So if you, I'll show you the example here. I have a byte example. See here, B1 I assign minus 128, it will work, and B2 I'm assigning some other value minus 50. So I'm printing both the B1 and B2. Here I declared B1 as byte type, B2 as also byte type. If I execute it, this program will run, and it is printing the value. So if I make 129, see compiler is showing me the error. Type mismatch cannot convert from int to byte. So when we are crossing the its limits, right? This data type won't support, and as our Java, as Java is a statically typed language, it well in advance the compiler gives this error saying that this data type is not supported. Like it is giving a different message that you cannot cast a byte to integer, means that it is indirectly saying use integer if your requirement is beyond minus 129 minus 128. So any value between minus 128 and plus 127 it will accept. So if I give some positive number like B2, I am assigning uh, some 100, I am on 100, it will work, right? See, it's printing. If I give 127 plus 127, also it will work because it is inclusive. Minus 128 and 127 both are inclusive values, including edge values. So 129 it will give error. So you see the limitation of a byte, right? So if your requirement is the small, like the range requirement is from minus 128 to 127, you can use. So ideally when we use it, like when we want to save the memory, because when we create a variable, right, uh, the type this Java allocates memory as per the type, right? Since it's a if you want to have a want to store a numeric value, but you want to conserve the memory, then you may use this data type byte. uh, and ensure that the value you are going to store is falls between this range minus 128 to 127. So this is about byte example, byte data type. Next we will see short. Short also stores the numeric value, but short is a 16-bit signed 2's complement integer. 16-bit, it allocates a 16-bit memory, and its range of the values it can store is from minus 32,768 to 32,767. So it like how this value comes is 2 power, in 2's complement representation, it will be minus 2 power 15 to plus 2 power 15, right? This is how the 2's complement representation of numeric values, right? So this is the range. So, and as with the byte, same guidelines apply. You can like if you want to save the memory, you may use the short. But your requirement, your value falls, if you know that between this range, within this range, you can use this. So I'll show the byte example also. Short example here I have written. So see, this is the smallest value we can store, and largest value will be any, like say 32,767. If I make 69, it will give error. See, it's giving error. So data type, variable name, and its value we are assigning. So then if I allocate positive value, some positive value, some 32,767, it will work. It's upper range value. So if I make 768, it will give us error. So range is for short, it ranges minus 32,767 to 768 to 32,767. It's a 16-bit. So this is the short data type. So if your numeric value falls like lies within this range, if you are sure of it, then you can use short data type. Okay. So the next one is integer. So integer is a 32-bit signed 2's complement integer. So you can store a large value between this minus 2 power 31 to 2 power 31 minus 1. So if your requirement exceeds this also, you can use. So long is 64-bit. Similarly, long is 64-bit 2's complement integer. So this range is from minus 2 power 63 to 2 power 63 minus 1. So these are for numeric values, right? Numeric values, I mean numeric means like integers. If you want to store integers, you can use them, right? But you will have a scenarios where you want to see decimal values also. For example, if you see if you see the currency, you can you never ever share them in the integer type. Now you need to store them with the decimal values, right? So for handle decimal type of data, we'll have two more data types. They are float as well as double. So float means it's a single precision system, 32-bit, right? So floating point always, single precision system. This one is, you can store up to 7 digits after the decimal point, right? So but thing is that for currency you should never use float or double, because for currency we should never have any restrictions on the decimal points, because it might look small to us, but if there is a loss of data and at the high cumulative levels means like if you club all the losses, it will be huge. That's why banks or financial institutions, for currency, they always use big decimal. You should never use float and double. But when we need to use float and double is, we need like where accuracy is not that much important, But we need to have certain amount of accuracy, like for in VFX gaming, also like machine learning or artificial intelligence, where if you want to use have some sort of accuracy but not exact accuracy. But financial matters, currency matters, where accuracy is utmost important, so we need to use big decimal. Big decimal will not have any restriction on the decimal points to be stored. So if you see the float or data type range, you know float yeah, float type. See, if you see 1.4, the range is 1.4 into 10 power minus 45. This is the negative value it can, minimum negative value it can store to, up to 3.4 into. So this is the one. So, and float can store up to 7 decimal digits after the, 7 decimal digits after the decimal point. If you see the double also stores that, right? But here it is 64-bit one, and after decimal point it will allow 15 to 16 decimal digits, so it's more accurate than the float. So, and when you are writing a floating data type, you need to mention f after your value, and for double you may mention it is d. It is optional. Mentioning d is optional, but you generally we put to indicate it as a double value. So suffix needed, here it is optional. So size is just 32-bit and it is 64-bit. So it all depends on your requirement, which decimal, which no data type you need to use. So there is one more data type, Boolean. Boolean, it's a single bit flag. Like we need just generally when conditional programming, this type of data type will be used to check status or flag some flags, like true or false conditions. It's a single bit data type. So a character is used to store single character. So generally it's a 16-bit Unicode character. So it starts with a 0 to the max is this one, 65,535, right? So single bit character. So one more thing is we need to mention character data type variable in single quotes. We also have string data type. String data type is a sequence of characters, so that used to store the text, plain text. So that's what. And we also wrapper data types, like these are all these are not objects, these are just primitive data types. These are not object, but we have exact representations of these data types in object form, that we call wrapper classes. For byte we have like for int we have integer. For long we have long class. We have float class. So double we have double class. We have object versions of these primitive data types. So we use like exactly both of them do same functionality, but thing is that object versions will provide additional methods to do some more activities, like, so object data types are more wrapper, we call them wrapper classes, but they have their own uses. That is about it. And if we if see declaring a variable is this much up to this point. This after that, this is a equals operator, that is in equals is nothing but assignment operator here. It does not mean like when you in Java, when we mention equal, it's like we are assigning the value on the right side to the variable. So it's called assignment operator. You cannot see it as in the strict mathematical terms. It is not that gear equals to 1 does not mean both are equal. Like when you write like this, we are assigning value 1 to the gear, right? So this is equals is the assignment operator. So this assigning a value to the variable is known as initialization, right? I mean, at the time of declaring, if you do this activity, assigning the value to the variable, that is called initialization. If you don't supply it also at the time of declaration, it won't cause any error, but it will have the compiler assigns default values to the variables if you don't supply values to them. So for different types of data types, we have uh, different default values. For byte, default value will be 0. For short, it will be 0. For int, it will be 0. For long, it's 0 long. Float, this one. Double, this one. Character will be this one. String or any other object. String is an object actually. So even though it's a primitive type, it's an object. By default, string is object, and that is an immutable object. Once you assign a value to the string variable, you cannot change it. It's a immutable. Okay, so default value, if you don't supply, it will have null. Null is nothing but it's a null value. It doesn't have any value. So null, apart from validating some objects, what they are existing or not, if they have value or not, just for validating purposes, we use this null one. Apart from it, null doesn't have any value in itself. So defaultly, any object, not only string, any class, unless initialized, it will have default value as a null. For Boolean data type, we'll have the default value as the false. So these default values are there, will be present if we don't assign any value to the variables at the time of declarations. Remember the local variables, as we discussed in earlier class, local variables, those are variables of the function which we define them. They don't have any default values. If we don't assign any value to a local variable, compiler won't assign default value to it. You need to assign a value before you use them in some other place, right? It won't give any error, but before using it, you need to supply the value to the local variable, otherwise it will give you the error. So now we'll see literals. Literals means like they represent some fixed value. Literals means like they represent some constant value. So like Java recognizes them, like okay, literals are the like code representation of a fixed value. See this, right? Boolean result, the result is a variable and we are assigning a literal true to this. So true has some meaning, and Java it's a value, and we are for one character, capital C, we are assigning this, right? C in single quotes. Here C is the literal, and numerical value 100, 1000, 10,000 are all these values are literals. So whatever we are assigning on the right side, that value is there, right? That we call as literals. So integer literals, we can for integer we can assign literals in either a decimal format or hexadecimal format or binary format, so it will accept, right? So we represent numeric values in different number systems, right? So this 26 is the decimal system, right? And the same 26 we can represent in the hexadecimal as this one, 0x1a, and in same 26 we can represent in the binary values. So we can assign the value in any existing number system, and Java will accept, right? So this is also possible. So we will all see that them in the our practice in this like after this. Yeah. So similarly, floating point literals are like this. So double d1 and 23.4, you can also write like this: d2 like 1.23 into 1.234 into 10 power minus 2. E symbolizes multiplication by 10 power, this is the value, power 2, 10 power 2. So if even if you write also, both are same, 123.4 only it represents. And floating point, as we discussed earlier, we should mention it has suffix f at the end, so it tells that it's a floating number. So for double it is optional, you may mention d here also, you may not mention also, both are accepted by our program, our Java. And similarly, character string, as we discussed, character holds single letter, holds single letter, and string holds a sequence of letters. It accepts the Unicode characters. So if you supply this, uh, like these are the Unicodes, right? We have from 0 to 65,535. If you supply any value to them, and corresponding letter will be taken. Suppose if you see for A it is 61, number 61. If I say character A equals to 65 if I assign, then actual capital A letter will be assigned. That also we will see in the code. And we also some escape sequences. Escape sequences means escape character also accepts some escape sequences, means escape sequences, they represent some particular type of functionality, right? So if you say slash b, it represents backspace. I mean, backward slash b means like it's a backspace. Backward slash t, it's a next new tab. Backward slash line feed. So these are carriage return, backslash. So all these things, suppose if you want to format some text or something like that, in such scenario we might use these escape sequences, that also supported by this character data type. So null is a special literal, as we discussed earlier. It just to check whether an object really exists or not. So apart from that, null has no specific functionality, and it is a default value for every object if it is not initialized. Okay. There is also a kind of literal called class literal. So class literal simple, for every class, if we append it dot class, if we write string dot class, so it represents the object type of the object. No, if we print it simply class, it only prints the class actually. So that's why we call class literal. We can assign class literal also, like, so it just prints the class itself, that's it, type of the class, that's it. So we'll see the and underscore in numerical literals. So underscore is what it does is, if you want to have some readability, when you see when you are assigning the big value, big numbers, like long, then to understand it clearly, like you just mention the underscore to enhance readability. Like suppose I have this social security number, right? This one, it's a long number. So then I can say, okay, 9 crores 99 lakhs 99,000, something like that. We will read like that, right? In crores, in lakhs and all. So you can separate with underscore, but it won't affect any of the it won't affect the actual number. Just for readability purpose, we will write like this. right? So also as we discussed, long number has can be appended by this L letter, right? So that's it from the data types. We'll see some examples here. We'll see. Um, See, here we have already seen byte example. Now we also short example we have seen. Float example. See, float. We declare float like this. Float is the keyword. As we discussed, the data for every primitive data types. Java reserves a keyword. If we mention it, Java will understand that okay, this variable my float number is of the type float, and it will allocate the memory accordingly. So this my float number I am assigning a 5.75 f. We need to give since it's a float number. So till 7 digits I can give. See, 2 digits are over, right? 10.99. If I give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 0, 1. Even if you print it, right, up to only 7 digits only it will take, not beyond that. If I print it, see how many I gave up to here only, it's printing up to 7 digits. You see, 6 or 7 exactly. We can't say it 6 or 7. So all of them are ignored. So that's why like these are getting trimmed, right? This floating point is getting trimmed to its upper value. So if you see, if I give double, it may accept up to some limit. It may accept it till up some limit, but after some point, I gave this much big number. Now if I print, see, I lost after 112. So this much big number decimal points I lost. Even double also can't handle it. So that's why if I have to store some my account balance in a bank, if I am losing this much amount, and if I club these losses of all customers of a bank, see how much big amount it could be, right? So that's why in financial system we always store values in the name of big decimal, big decimal, java math dot big decimal. So big decimal, we need to import that class. So it's a double value, right? And so how to I can typecast. So we'll search uh, storing big decimal values java. We'll get, yeah, we have to use value of big decimal dot value of method. Since big decimal is an object, big decimal dot value of. Yeah, now it should work. It will print. See, now it is printing all the value, right? Exponential 38, but it's giving accurate, it's not losing the value, right? So that's how we will, no, sorry, 9 point, yeah. Yeah, this is how we are storing it. So we need to use big decimal, like when dealing with the currency values, So that's the take from this. So avoid using double and float values for currency values. So use only float and double when the accuracy is not that much important and we need to save the memory. Then you please use this floating and double data types. So that's done, and similarly, what is left? Uh, Float double long also simple. When our integer, our requirements going beyond integer, or we want to store bigger numbers like this long large number, this one, like this much big numbers, we need to use uh, long data type. So this L is not needed, it's optional. So that's it. So if you want to see any data type of any data types max or min value, you have for every type, like for every wrapper class, like I mentioned wrapper classes, right? Object versions of the data primitive data types. You have max value, min value methods. You may see from them what max and minimum values they can hold. Like you can programmatically determine them. So, for example, here max value for long will be this one, and min value will be this one. Similarly, float, I have written this method, like not float. So yeah, you can do for float also. So that's how you determine max and min value. Similarly, for character data type, if you see, I can store single letter a, character literal, we say character literal also I can assign, and also I can add a numeric character. Numeric character means like 5, if you put in double quotes, it's a numeric character. That also we can do. I can also assign a Unicode. So Unicode version also, it will be, so it will print corresponding, uh, corresponding character. If I mention the numeric value of that numeric value also, it will print corresponding representation in Unicode for that character. So 65 represents capital A actually. So that is how we can assign letters to character. I mean that we can use the character data type. So if I print it, you see, so this one represents in UTF-8 format, like this one represents A. So similarly, 65 also represents A. So this 5 is the character numeric literal 5 is printed, and this one also I printed. So this how we use the character data type. Similarly, strings just stores the sequence of a character. So if I write for string, I can write like this: string name. I'm assigning name, my name, like Vikram. So see this. So this Vikram is a sequence of individual characters, right? So letters, right? Individual letters. So it's a sequence of letters. So to store them, I'm using the string. So string generally used to store the text. Okay. So that's all about the data types. So we'll see in the next class. Next topic. We'll come up with the next topic.